All right. Thank you for coming back. It means you really want to know more. Click the subscribe button and then ring the bell on Peg Tutors so that whenever we release any new videos, you'll be the first to be notified, right? So we are still talking about the AC circuit. Yeah. So if you check our previous videos, you see where we stopped, and we said we are going to continue in our next video from the connection of the capacitor in the AC circuit. What effect does the connection of capacitor has in an AC circuit? So imagine the capacitor C in an AC circuit. So what is its effect in an AC circuit? So we draw the AC circuit, and then we have our capacitor. This is a symbol of a capacitor. Then this is a symbol of our AC as usual. So we have this capacitor is C, and these are AC source. Okay, and the AC current and AC voltage moves through here. So the question now is, what is the effect of this capacitor connected in an AC circuit? When a capacitor is connected to an AC circuit, the current leads the voltage by 90 degrees. Remember, for an inductor, the current lag behind the voltage by 90 degrees. Voltage leads current by 90. But in this case, current leads voltage by 90. So our I, formula for our current, now becomes, that's the AC current now becomes peak current sine WT plus 90 degrees. Remember, okay, while our voltage, that's our AC voltage, becomes VP sine WT. So like the inverse of when inductor is connected. Now, at this point, the question now is from the Ohm's law. Remember that V is equal to IR, right? And the same thing we did for an inductor, the same thing we are going to do, because this R ceases to be R now. Remember, capacitor is the one being connected. So I mentioned in the last video that the resistance that the capacitor offers to the AC circuit is the capacitive reactance, which is XC. Okay, so in this case, our V now becomes IP, then XC, where XC is capacitive reactance. And this capacitive reactance can be calculated, XC, as 1 over omega C. Okay, where omega, remember, is still the same thing as 2 pi f as usual, and our C is our value of capacitor, the value of capacitor. Okay, so it will be given to you in the question. All right, so you come back here to do your calculation. After you found your XC, you bring it back here and do any calculation you wish to do. Now, at this point, let us take one example with this capacitor in an AC circuit. So this is the question we have. It says a 400 ohms resistor is connected in series with a 50 microfarad capacitor. It said the voltage across the capacitor VR is equal to 2 sine 100 pi t. Remember this equation, this formula is for voltage, AC voltage, sine WT, okay? And the W there is 100 pi. So when we are solving, we should note that. And also, capacitor is measured in farad, but not, they put it in microfarad, which is times 10 raised to power minus 6. So also convert that before you solve. Now said we should calculate the capacitive reactance. So what we have here is, let's draw our diagrams first, okay? Infusing the capacitor. This is our AC source, okay? So these are AC source, and this is a capacitor which is 50 microfarad, and we have this. Okay, so what they said we should calculate there is the capacitive reactance. But remember, from VC, we have capacitive reactance as IPXC. Okay, but what they want us to calculate here is XC. So so now they want us to calculate XC. So therefore, XC, remember, is 1 over omega C. Okay, where omega here is, remember, 2 pi F. But then they didn't give us anything like frequency and all that. But they gave us this equation. Is a clue to get our W. So this is our W because here it's supposed to be WT. But we have the T and the whole W is represented with 100 pi. So we come here, that will be 1 all over, okay? 1 all over, that will be 100 pi times C is 50 microfarad, which is, of course, 50 times 10 raised to power minus 6. So if you blast this very well, you calculate this and blast it very well, you'll have 6.36 times 10 raised to power 2 ohms. Okay? Remember, this pi is 22 over 7 while running the whole of your calculation. All right, we'll meet in our next video where we'll be talking about, we have done the resistor in the AC circuit, we have done the inductor in the AC circuit, now we have done the capacitor in the AC circuit. We're going to be looking at resistance and inductor connected together in an AC circuit in our next video. Check the next video for the continuation. Thank you.